So, as Alex said, this is very much going to be a fast-paced presentation. So let's have a quick look at what we're going to be covering today. So in this session, what are we going to cover? We are going to have a look at what is a graph and why I think they're absolutely amazing. We are then going to go through some quick scenarios that you can look at so you can identify when the problem you're looking at probably is a good fit for a graph database. We are going to look at the anatomy of a property graph database, and I'm going to give you a super quick introduction to Cypher, because then we are all going to be doing a hands-on example in the Sandbox, and we're going to be working with our very first graph, which is a small movie graph, and we are going to go from finding actors within that movie graph to building our first recommendation query. Absolutely, in this session. We're going to be doing that with Sandbox, so you can do that now. It probably doesn't hurt if you have half an eye on getting Sandbox there, if nothing else, just to get registered and set up on that. And then we're going to be using the blank Sandbox for that. And then I'm going to give you some information about how you can continue on your graph journey. So what other resources are available to you, how can you improve your learning, and so forth. So, without further ado, what is a graph? A graph is a discrete set of objects. So you can think like a person or a car or something like that. Or it can be other things as well. And each of these discrete objects may have a relationship with another discrete object. And this comes from graph theory. So very famous mathematician Leonhard Euler came across this maths problem, which was the 7 bridges of Königsberg. So this was in Prussia, now modern day Russia. And they had these 4 land masses, so 2 islands and 2 parts of the mainland. They had this river running through it, the River Pregel, and they had these 7 bridges. And somebody thought, this will pose an interesting question. Is it possible to visit all 4 land masses using those 7 bridges, but you can only use that bridge once and only once? And Leonhard Euler came across this problem and went, well, actually, what I need to do, what I think we should do to solve this problem is we need to simplify this. And effectively, what he said was, well, those 4 land masses, so the 2 mainlands and the 2 islands, those are our discrete objects. And the bridges that are connecting them, well, these are the relationships. These are the things that are connecting the land masses together. So that is where graph theory came from. That's where it was born. So I'm going to not dive too much into that. Do have a look at the 7 bridges of Königsberg. It's a fun problem. There's plenty of content about it on the internet. And absolutely anything can be a graph. So the internet can be a graph, and there's lots of different ways the internet can be represented as a graph. So let's think about, let's take e-learning as an example. We're all here, we're doing a lesson. And you think about, well, how do we use the internet for learning? So we may have entities such as webinars. So we've got this webinar now that we're doing. That could be an entity. The other ways we may learn, we may use Wikipedia and other web pages. So we'll have websites we may have. And you think about the different ways that we're connecting these different elements together to learn, or how we're connected to each other. And we think about how we contact each other. So maybe we send each other an email, maybe we send a text message, maybe we phone each other. So you're thinking about us as people being the discrete entities, and the relationships could be representing the different ways we communicate with each other. And also just thinking about the physical setup of the internet itself, the fact that we are connecting to the internet with our laptops, our tablets, our mobile phones. If we think about the Internet of Things, so we've got our smart devices, we've got monitoring devices that are connecting and sending information around. Even if we go down to the level of the actual physical connections of the wires, the cables, the fact that we're using Wi-Fi, the actual metal in the tin, there's so many different discrete entities you can picture when we think about the internet and how they're connected. A water molecule. can be represented as a graph or as a graph. And if you think about the construct of a water molecule, it's not just that we've got an oxygen atom and 2 hydrogen atoms. It's specifically how they're connected that gives you a water molecule. And it's the fact that the oxygen molecule has 2 relationships with hydrogen atoms in that specific way and not in any other configuration. So absolutely anything can be a graph. So why are graphs amazing? Why do I get so excited when I think about graphs? So I've got a bit of a contrived example here, but I'm using this example of trainers. And I've got this scenario here. We've got these 3 people, Jane, Alison, and Ian. And they have all at some point bought a pair of trainers. And I think there's a little bit more going on here in this scenario, because if we have a look, we can see Jane bought the trainers first, then Alison, then Ian. And let's say in this scenario, I can pull in data from different social media sources. And I'm going to dig a bit further about what happened here. So Jane bought these trainers. So you can we've got the discrete entities here of person and product. So Jane buys these trainers and she's really happy about them. So she goes onto Twitter, she posts a new tweet, "I love my trainers." It turns out that Alison follows Jane on Twitter and she reads the tweet, and that influences her to go off and buy those same trainers. Alison, obviously also very happy with these trainers. So she's on Facebook and she posts an update saying that her trainers are brilliant. Okay, so then we have a look and see what else is going on. Turns out Ian is friends with Alison on Facebook, and he reads her update on Facebook about the trainers. That influences him to buy the same trainers. He's obviously happy about them. He posts a picture of them on Instagram and so forth. So you can start to see this really interesting journey of connectivity. So we're looking at this story of 3 people buying trainers, but it turns out there's a lot more going on. And by using a graph, we're able to understand these connections, these relationships between not only this connection that they're all buying these trainers, but what might be driving this journey as well. So I'm going to pick a very popular one. So this one came up a few years ago, which is the Panama Papers. And this was driven by a very simple model of how things are connected, how these discrete entities are being connected. But it had some really powerful outcomes. So I'm going to talk you through this. So don't be too frightened. I know we've got a few notes here, but let's just talk about what's going on here. So what we have is this idea of an entity, and an entity could be an officer. So this is a person who may be a director of a company, or they have shares in a company or something like that. This entity can also be an intermediary. So if you think about, you can have intermediary companies. So you may have a big company and then it gets split up into smaller companies. So these are called intermediaries. Or maybe we're not entirely sure what this is, but we're just going to refer it as a generic term of entity. And the key thing here is that if we think about what an entity can do, so this entity can be a shareholder of another company. So basically this entity owns shares, owns interests in another company. This entity may be an officer of a company. So they have some, they have some influential role within that company. They may be a director. So they are one of the bosses of that company. And so you can understand. So we've got these different ways that these companies are linked, but all of them have a registered address. So they're all based. So all of these entities will be registered somewhere. And what's really clever about this is that we've got a relatively simple thing of either you're an entity or you're an address of that entity. And what this allows us to do is very quickly, we can follow all of these connections to see an example of the Panama Papers, that if you had a registered interest in Panama, which is what was happening here, where people were ultimately saying that their companies were registered within, ultimately registered within this company, that we could follow these connections and then find out whether, for example, the former Icelandic Prime Minister had interests in Panama where they were using that for tax evasion, tax avoidance, and that kind of thing. And such a simple model had such a big influence in the world. And another quick one is thinking about Facebook or LinkedIn or all of these other platforms. And you think about when it pops up and it goes, hey, you may know these people. And you think, well, what's going on here? And effectively what's happening is by understanding the relationships that you already have with other people, we can try and make predictions about who else you might know. And just as an example, if I'm friends with Anne, Dan, Zane, and Jane, and Bob is also friends with Anne, Dan, Zane, and Jane, we can say, well, because we've got so many friends in common, there's probably a good likelihood that Bob and I know each other as well, but for whatever reason, we haven't connected yet. And so you think about this friends of friends problem. And we're going to be looking at something similar later, which will be co-actors of co-actors when we do our hands-on example. So let's have a look at some ways we can quickly identify good graph scenarios, because not everything is a good graph scenario. Not everything is looking at the relationships between entities and examining those relationships. So what I'm going to do now is give you 4 scenarios to very quickly go, right, okay, this is a graph scenario. So number 1, does our problem involve understanding relationships between entities? So this is quintessential graph, isn't it? So just as a quick example, we looked at trainers previously. So let's look at, with this theme of product. So here we've got 2 customers, Lisa and Jane, and they both buy a product. So both of them buy a t-shirt, but they're different t-shirts. So Lisa buys a red t-shirt and Jane buys a blue t-shirt. So they're different t-shirt products. They've got different stock keeping unit IDs and so forth, but they're both t-shirts. So they're both of a product category of t-shirt. And how we can use this understanding the relationships between what customers buying and the product is, well, if there's a series of products. So we've got a product of t-shirt, and let's say Lisa also buys a product of sunglasses and a product of shorts and a product of a baseball cap. So those products are probably leaning towards some kind of buying behavior or pattern. You know, it could well be Lisa's going on holiday. And if we look at Jane, and Jane also buys a t-shirt, and she also buys sunglasses, and she also buys a baseball cap, we'll go, well, hang on a minute. The product categories that Lisa and Jane are buying are very similar. So maybe we should recommend to Jane that she'd be interested in some shorts, as an example, because this is a common thing that other people buy alongside sunglasses, a baseball cap, and a t-shirt. So this is great. So we understand those properties. So the kinds of places you're going to see these situations where we're understanding these relationships between entities will be recommendations engines. So we just talked through an example here. Fraud detection. So are there behaviors? So are people reusing the same details, such as a phone number, landline phone number, or an address, or social security number, that kind of thing. Finding duplicates. So again, same idea. If we've got many instances of customer in because we have legacy systems, or we've been joining lots of companies together, we can use these graph structures and look in the similarities to be able to deduplicate our data. And data lineage, just understanding if we take a piece of data and we keep transforming it and moving around our system and that kind of thing, just understanding what's happened to that piece of data as it's traveled around the system. Another scenario for spotting good graph, good graph fits would be, does the problem involve a lot of self-referencing to the same type of entity? So what do I mean by this? Let's think about an organizational chart. And here we've got the same type of entity, employee. So they're all employees, and we've got different employees here. So we've got Jane. Jane manages Jason and Joe, and Jason manages John. And here we've got a lot of self-referencing, because if I wanted to understand all of the direct and indirect management relationship Jane has throughout her team, you can see we're constantly looking at the node of type employee, and we're trying to go down that tree. So you sense in these in organizational hierarchies, what we've just looked at. Access management, so understanding what rights you've got to a document, and you can see lots of self-referencing with regards to teams allowed to access that document and any special privileges. Social influencers. So if you want to understand who people are following on Facebook. Oh, I've just realised I've left an overlay for the Sandbox. One moment. Get rid of this. Sorry about that. I've just removed the overlay. So if we want to understand here things like social influencers. So if you think about what we're dealing with here, you're literally just going to have people nodes and how people are connected to other people and who's reading whose posts and who's sharing whose posts and who's posting and that kind of thing. So here is a great example of where you are looking at these self-referencing and you're seeing, well, who's got lots of outbound messages? So whose messages are continuously being forwarded and retweeted and that kind of thing. And friends of friends. So again, like we spoke about earlier, understanding that if you've got large groups of nodes where people have got common friends, but there isn't a connection between those two particular entities, we can make those predictions about who knows who. Scenario number 3. Does the problem explore relationships of varying or unknown depth? So what am I talking about here? So I've got a very simple example of a supply chain. And we have this company, We Sell Wood. And We Sell Wood, you'll be surprised to hear, sells processed timber. So they sell wood to this company called Pencils R Us. And what Pencils R Us do, they take raw materials of wood and graphite, and they then go off and turn those into pencils. So that's what they produce. And the pencils are going to be sold on to various stationery companies, including one stationery company called We Love Stationery, which sell stationery. So they buy products such as pencils and pens and pencil sharpeners and post-it notes and all of that good stuff, and they sell them on to other companies. And We Love Stationery sell pens to We Sell Wood, because We Sell Wood like to write stuff down and write their orders and that kind of thing. So you can see here, we could potentially have lots of varying depths of relationships. So the fact that Pencils are also going to be buying graphite. So how is that graphite being made and that kind of thing. And now what we can start to do is explore, well, what happens if We Sell Wood, which is a family-run business, you know, it's been in the family for generations, but they've decided, you know what, we're going to retire now. Timber isn't us anymore. We're going to have a quiet life. But what's the knock-on impact of We Sell Wood now closing down because they're retiring the business? So Pencils R Us suddenly have lost that source of that raw material. So what happens there? So that knocks onto their pencils. And then this potentially has a knock-on impact on We Love Stationery, both from where are the pencils going to be coming from? So then do they need to start finding other organisations that sell pencils? But also, they're no longer selling pens to We Sell Wood. So you can start to see how we explore these varying depths of relationships to work around this. So I just noticed there were a question, is this going to be recorded? Yes, this is going to be recorded. This will be available for you to review. We'll share the slides. All of that will be available to you. So some examples of where you might see this scenario would be supply chain visibility. So we just had a look at a simple example here. Bill of materials. So when you think about when you're ordering a new laptop from a very popular company, or if you're buying a car or something like that, you know how you can configure certain things and you can pick, you know, what size wheels you're going to have in your car, what extras, but there's going to be dependencies because you can't, for example, have the 20-inch alloy wheels with the 19-inch tires or something like that. So you're going to have various rules that fill in there. And network management, and you think about exploring the dependencies of what happens if a certain router goes out, what's going to be the knock-on impact of that happening. And the last scenario here is, does our path involve discovering lots of different routes or paths? And this is a very quintessential graph problem. This is very much when you think of graphs, you go, yes, logistics. So let's pick an example here. And this is a topical one from about 18 months ago, back in the days when we used to travel. And I went up to a conference, which was in Edinburgh. And I went up by train. And on the way out, I went up the East Coast. So I'm based in London, and I went up the train and we stopped at York and Newcastle until we eventually got to Edinburgh. And then on the way back, I went down the West Coast. So that was going via Lancaster and Crewe and Rugby back to London. So this is a great example of where usually when people think about graphs, they're probably thinking about logistics and route planning. And this is very graphy. So this is if we want to try and figure out different ways of getting places. Maybe we want to put some weighting onto that. So we want to understand what's the quickest way to get there based on speeds. Maybe we want to understand what's the cheapest way to get there because maybe there are other costs involved and so forth. And you'll commonly see this in logistics and routing, as we just looked at that. Infrastructure management. So if something goes down, so we talked about a router going down, how do we reroute to make sure that other systems are not being impacted? And dependency tracing. So again, we can start to understand if there's a single point of failure, what are we going to do about it? So how can we put in some kind of replication so that we're not impacted? So those are 4 high-level graph scenarios. So what we're going to do next is look at the anatomy of a graph database. So I saw there's some questions coming up about, can you have attributes? Absolutely. And we're now going to look at that. So very quickly, the components, graph components, are nodes. So these are distinct entities. Sometimes they're called vertices, or they're called vertices within graph theory. And this is the main element for what graphs are constructed. And then we have something that connects them. So these are the relationships, also known as edges. And edges only exist if the node exists. So you can't have a relationship sort of hanging without a node. So whilst a node can live on its own without any connections, a connection must exist between 2 nodes. And you have direction on a relationship, and you have a type. And we're now going to look at this should be property graph database. I will update the slides before I send them out. But here you have got the nodes and the relationships, which we talked about earlier, but we also have some things to describe them with. So we have labels on our nodes, and this is a way to provide a category for our node. So we've got an example here. We've got node of person, so that's one category, our label, and we've got another one of car. And you can have more than one label. So in Neo4j, you can have more than one label. So if we had one example, we wanted to understand what car somebody owned, that's great. But if we were looking at insurance perspective as well, and we want to know about assets, and an asset can be a car, an asset can be a house, an asset can be a TV, and so forth, maybe we want to add more labels to describe that. And then we have properties as well. And properties allow us to enrich our nodes and our relationships. So for example, with our labeled person node, we can put a name on there for Jane. For our car node, we can put some properties on there about what make that car is, what model it is, and so forth. And we can put properties on relationships too. So for example, if we want to know when did the person node of name Jane own this car asset of make Volvo and model V60, we can put in a property of a date. And we don't need to have null. So if we were also capturing Twitter handles, for example, and Jane does not have a Twitter handle, we don't need to put in handle : null. We can just put it, we just don't bother putting in at all. So we're going to do a quick crash course in Cypher before we have a go ourselves. So how do we query the graph? We query it with Cypher, which is Neo4j's graph query language, and it is made for graphs. It is a declarative language. So what do I mean by this? You have 2 types of languages. You have declarative and imperative. So with an imperative language, you have to give specific instructions. So for example, if I ask to my husband whether it's raining outside, an imperative language, I would have to give him very specific instructions about how he would check to see whether it was raining. So maybe I will tell him, go downstairs, go to the back garden, stand outside, look at the sky. If you see anything dropping or you get wet, it's raining. A declarative language, you just basically say what you want. So I would say to my husband, is it raining outside? And then he would decide what is the best way to answer my query. He may decide that the best way to do that is to just go look out the window. He may decide to go outside and see if he gets wet. He may decide to have a look at a weather forecasting website and tell me what the current conditions are. The point being declarative is I ask what I want, and Cypher's going to figure out what's the best way to answer that question for me. It's expressive. It is very much what you see is what you get. And you'll see an example of this later where you'll see how the query matches very closely to the question that we're looking to ask. And it's pattern matching. So what we can do, as well as providing a very specific start point, so for example, who does Bob know? We can ask certain patterns where we can say, bring me back chains of where, 5 people know 5 other people, for example. So we have this very powerful pattern matching language. And we do it with ASCII art, and it's great fun. So let's have a look. For those of you who are on Big Marker, you will discover you have a handout. The handout is this slide. So very quickly, nodes and relationships at a glance in Cypher. If you see just a round bracket, so all nodes are represented by round brackets, it's a node. If you see anything like this, so two dashes or 2 dashes maybe with an arrowhead, so this is giving you direction of the relationship, or you might just see 2 dashes and square brackets. These are relationships. And notice they are completely plain, so these are generic nodes and relationships. We can add a reference. So if we want to come back to a specific node or data about that node or data about specific relationships, we can add a reference. So you'll notice we just pop them in like this in this context. If I want to refer to a specific node with a specific label, I will do this context of :person. If I want to refer to a specific relationship type, I will do :type. Notice we are using either the round brackets for a node or the square brackets for a relationship type. If I wanted to refer to a specific node with specific property or a specific relationship type with a specific property, I use the curly braces. So look, it's curly braces either for a node or a relationship. We use a key value pair setup. So in this example here, this is the key here, which is name, and then the colon. And then here I've got a string for Bob, or for this example here for relationship where I'm looking at role. Again, the same pattern. And if I wanted to have a reference to a specific node with a specific label and a property, or a reference to a relationship with a specific type and a specific property, then we do this. So the way to remember this is for a reference, the reference is always to the left of a colon if we're using either a node label or relationship type. If we're not using labels or types, it's just on its own like this. So I'm going to go into this a bit more detail, but for those of you on Big Marker, you've got the handout there and you can refer to this when we are doing the hands-on example. So very quickly, if we want to retrieve nodes, we use the keyword match. So if I wanted to match all of the nodes in the database and bring them back, as we spoke about before, we use the round brackets for nodes. And here's my reference. So this here is going to say match everything in the database and give it a reference of n, and then return will return, and this will return all of the nodes in our database. If I go, no, actually, I just want to return all nodes with a person label in my database, then again, same idea, round brackets because we're dealing with nodes, n:person. So this is now specifying our label of person, and return n will return a reference to all of the nodes with a person label. If I go, well, actually, no, I want to return all nodes that have got a person label and have a property of name Tom Hanks, then what I would do, so again, here's our reference n. I now specify the label. And as we said, everything in curly braces is a property. So curly braces here, name, Tom Hanks, return n. This is going to return all nodes with a person label that have the property of name with the value of Tom Hanks. But we go more. So what if we go, well, actually, I'm probably going to be doing ranges of things, or maybe I only want to find person nodes that contain the name Tom. So what we described earlier with properties, this only works with exact matches. But what we can do is use the where keyword. So similar to those of you who are coming from SQL, we have where. And what we can do here is if I wanted to say match all person nodes, put it in my reference P where the name is Tom Hanks, we can do this as well. And this does exactly the same as the previous query with the curly braces. So the difference here now is we're not using the curly braces because we're using the where clause. And we use this dot notation. So we're using our reference, and our reference here is called P. So where P dot name, so this accesses the property, and we use this both for relationships and for nodes. So where the reference identifier dot the property equals, and whatever our property is, return P. So that will return all of our nodes with the label of person and the property name of Tom Hanks. If I said, well, actually, what I want to do is I want to return all nodes with the label of movie, but I want to have all of the movies that were released between 1991 and 1999, then I can use this, again, very similar to what you'll see in other programming languages and within SQL. I can do this match and movie. So this is going to match all nodes with the movie label on there, where m.release, so released is our property that we're using for the year. So where m.released is greater than 1990 and m.release is less than 2000. And that is going to return all of our movie nodes where the release property is between 1991 and 1999. So return M. Fantastic. Don't worry, we'll go at this a bit slower pace when we're doing the hands-on examples. This is just to prime you with what we're looking at shortly. But obviously, it's not all about nodes. We want to know about the relationships as well. So if we wanted to find all of the movies that Tom Hanks is connected to, well, we know this bit. We match we match person, so that's our person label. We're looking for Tom Hanks, and then spot here, we talked about that generic relationship earlier. So we've got, this is our relationship here, 2 dashes. And then we go to our node. So we want to know about the movie nodes. So here we've got colon movie. Here is our reference for the movie because we want to bring back some information about that. So m colon movie. And then we're returning the title. So m.title, this will return all of the movie titles that Tom Hanks has some sort of a connection with. If we said, well, actually, we want to be a bit more specific, what I want to do is I want to return all of the movies that Tom Hanks has directed, and a little bit further, I want to order them by the newest movie. So again, this is familiar. We are matching our Tom Hanks node, so we're looking for a nodes with a person label with the name Tom Hanks. We're now specifically specifying a relationship type, so directed. And then again, movie. So we've got our reference for movie here. And we're returning the title. We did that previously. We're returning the release year. So again, we can return more than one property. And then similar syntax you may be familiar with. We're now doing order by. So this is where we're saying, actually, we want to specify how we return our list of results. So order by m.release descending. So by default, order by always returns in ascending order. We're now specifying this to return in descending order. And if we say, well, actually, what I want to do is I want to find all of the co-actors of that Tom Hanks has worked with. So actually what we're saying now is we're jumping out to the next node. So we're now moving out to a second node from our Tom Hanks node. So we're saying here, this is our Tom Hanks, this is where we're starting with. We're now going from movie and we're now finding the co-actors. So again, we're starting off with our Tom Hanks start point. We want any relationship, we don't mind any kind of connection that Tom Hanks has with that movie. And then we're saying, well, specifically, we want to know his co-actors that he was working with. So we then put in the acted in relationship type. So we're specifying the relationship type. Notice again, we're using the square brackets because we're specifying specifically something about the relationship. And then we go out to our person nodes. And we've got a reference called co-actor. And then here we're going to return the co-actors' names because we know our person nodes have a name property. If we want to create some nodes, then we just switch out what we had before for match. We switch out with create. So if I want to create a person node with the name Tom Hanks, I put in create, the label, and the property. If I wanted to create a new relationship between 2 existing nodes, I would first go off and find these existing nodes. So I'm going to match my person node for Tom Hanks. I'm going to match my movie node of title Apollo 13. And then what I would do is I use my references that I've created. So P for Tom Hanks, M for the movie Apollo 13. And then again, I use the create and I'm saying create acted in relationship between M and P and M. So good. One thing I'll mention, when you are doing matches, you do not need to specify a relationship direction. When you are creating a relationship, you must always specify a relationship direction. So it's not important when you're doing any kind of read queries, but you do have to specify one when you are creating the relationship in the first place. And if you wanted to create the entire pattern, so you want to create the Tom Hanks node, you want to create the Apollo 13 node, and you want to create the relationship between them, then you can do this, and this will create the entire pattern. Now, bear in mind, it's not going to check whether this stuff already exists. It's just going to go away and create it. So just a quick question. For those of you who are posting questions, I will pick those up as we go along. And definitely when you're doing the hands-on thing, I will be going through all of your questions and answering those. So don't panic. Keep putting those questions in. If there's something here that's not clear, I will pick those up as we go along. Okay, right. I've been speaking now for a while, and it's now time for you all to have a go. So you will need to get the Sandbox. So I'm going to join you as well. And so you need to go to sandbox.neo4j.com. You can either use your social media login option. So I'm going to be using Google myself, or you can create your own. So you can specify an email address and set that up. But you're going to set up, and we're going to be using the blank Sandbox, and you're going to launch that, and we're going to be doing this all together. So I'm going to go off and go to Sandbox myself. So when you come in, you'll have something like this. So I'm going to click on the new project. So for those of you who may have popped up with new projects, and then what we want is the blank Sandbox. So that's what I'm going to be selecting. That's what I'm going to be running with. And then I'm going to press launch product, that. So it's going to give that a few moments whilst it loads up. So I'm going to give you all a couple of minutes to get yourselves set up. So get yourself onto sandbox.neo4j.com if you're joining in to get that new Sandbox booted, and then we will continue. When you start desktop or Sandbox and you press open, this is what you're going to be. You're going to be greeted with something that looks a lot like this. So this is Neo4j browser, and this is a tool that allows us to explore the data. It allows us to write some queries. We get to interact with sample data that comes back. So it's a really nice way to do it. So for those of you who've got it working with Sandbox, press the open button and you will be seeing the same thing as this. So what we're going to do to get started is we're going to do this : play movies. And this is going to start the movie graph. Okay, so you will do play movies. So it will look like this. That's what you want to do for those of you who've got it working. And this will start up this frame here. So let's do a quick tour of Neo4j browser. So these are frames. So this is what we call a browser guide. And you can see we've got some arrows here, and this allows us to navigate through examples. So for those of you who noticed on Sandbox, we had loads of different examples. So each of those examples will come with a guide, and that allows us to navigate through various examples. It will give us an explanation. We can click through queries. So I'll give you an example of that shortly. And just some other bits and pieces going on. What you'll notice is you have some buttons here, and this will give us information about our database. So you notice there's not much here because we don't have any data. So we'll come back here in a second once we do have some data. So one thing I recommend to all of you who are following along is you'll notice there's this picture of a pin. So if you click on that, that's going to make sure that this frame stays at the very top so we can see what we're doing. Okay, right, let's do some querying. Less talking, more querying by Lou. Let's do this. So we're going to advance this browser guide by pressing the arrow button here. And what you will notice is we've got this grey box. And what you'll see that anything in a guide with this grey box means that we can click on it. And what will happen is it's going to send that code up here to the top. So here we've got this. This is our query pane. So this is where we write our queries. And if we press the play button, it'll run those queries. So before we run this query, let's have a look what's actually going on in the query. And what you can do is if you want to make this a bit bigger so you can see what's going on, you can press these two little arrows here. And that's going to expand it out. So I'm going to just quickly talk through what's going on. And then for those of you who've got the browser window up and the database is running, you'll be able to execute the query. So very quickly, let's have a look what's going on. So we've got create. So create means we are going to be creating some data. So this query is going to go off and create some data for us. Fantastic. So let's explore what's going on. So we can see straight away, we've got this colon movie. So we're going to be creating a node with the movie label. Notice here we've got our reference this node and we're calling it the matrix. And we've got curly braces. So we are adding some properties here as well. What you'll notice is we talked about we're creating a movie node. And then here we've got 3 properties. We've got title. And you notice that we separate more than one property with a comma. So we're separating with a comma. So here we've got a title. We've got a release year for the movie. We've got a tagline as well. And you notice here we're doing loads and loads of creates. So we created a movie node, then we're creating some person nodes, same idea. So we've got a reference to that node that we're creating. We've got the label for that node that we're creating. And here we've got a couple of properties. So here we've got name, Keanu Reeves, and the year of birth. So you notice here we're creating we're creating a movie node and a load of person nodes. And then afterwards, what we're doing is we are creating the relationships between them. So notice how now we're using the references for the nodes that we've created, and we're now creating the relationship between there. So because we're creating a relationship, we have to provide a relationship direction. So we're doing that here with the arrow. You can notice we're providing types. We must provide a type when we're creating a relationship. And we've got some properties. And for those of you going, whoa, hang on a minute, why have we got something with square brackets? So in this context, for the property, we're creating an array. So if you think about in your most of your programming languages, we use square brackets to represent an array. So here we're representing an array of roles. So that's the only reason why we've got the square bracket there. And you will notice as we query the data that one of our items has more than one role, so which is why we have that array. So we create a load of data, and then at the very bottom, once we've created all of our movie data and our actor data, is you'll notice we have this query here, which is with Tom H as A, match, and you're going, oh, hang on a minute, what's going on there? So what's going on here is with basically says, remember that reference that I made a while back? Please bring this reference. So with this reference, I'm going to continue and do some more stuff. So that's why we've got that with. As allows us to re-alias or create a new reference name for our existing reference. So what we're saying here is, well, we know we had a reference called Tom H. We're now going to refer to it as A instead. So it was Tom H. Now we're calling it A. And we've got match. So we're now going to match some data that we've created and return it. So match A, which we know is the Tom Hanks node. It's a reference to our Tom Hanks node that we created earlier. Then match all of the movies. So we know that's a movie node because we did that pattern of person to movie to person to movie. So get all of the nodes, which we're going to give this reference of M, where Tom Hanks has an acted in relationship with. And then from there, we then want to pull all of the nodes with reference to D that have a directed relationship, return AMD limit 10. So what's happening here is saying, so with the Tom Hanks node, match all of the movies that he's acted in, find all of the people that directed those movies and return all of those, but bring back the first 10 finds in that database. So that's what's happening. We're creating a load of data. We're then saying with Tom, we're then going to go off and find the directors of the movies that he's acted in. I'm going to limit to 10. And the question that Jesus has just asked, which 10 matches? It will literally be the first 10 in any given order that the database returns. Because we've not specified an order by or any other parameters like that, it will literally be the first 10 that the database finds. And if there's been a previous query where some of those nodes have been hit, so the database does this thing called caching, it could even grab those. So it will be completely, I say at random, it's not strictly at random, but we've not specified it. So it'll be the first 10 that the database sees or is aware of. That's what it's going to return. So I'm just going to span this back and we're going to run and create some data. So I'm going to press the play button now. It's going to go off and create some data. Now, bearing in mind that we pressed that pinned button, so that means all of our queries are going to pop up below. So I'm just going to scroll down and here we go. So I'm just going to expand this. We've created our data and then we used our Tom Hanks node to bring back some information. So you can see here, we've got our Tom Hanks node. We've now got the movies that he has acted in. So these are in blue, they've popped up here. And then we've brought back the directors of those movies. Neat, eh? We've just created some data in our database and we've now brought some data back. Fantastic. So, okay, I'm now going to press the next pane. And what we're going to do for you all is I'm now going to leave you. I'm going to give you a few minutes. And what I would like you now to do, we've got a number of queries here, and I want you to take this approach. I want you to first look at the query and think, what is that query going to do? Then run that query and see what happens. And just for a bit of fun, which you can have a play with, definitely when you obviously rewatch this recording and have another go in your own time, is you can take some of the nodes and double click them. So this Sleepless here, Sleepless in Seattle. If I double click on it, you'll notice it expands out and I can now explore the other nodes that come off it. So I'm going to give you a few minutes to look through each of those queries, try and guess what's happening in that query, run that query and maybe have a bit of a play. So let's give that about 5 minutes and then we're going to move at pace. So whilst you're doing that, I'm going to go through and answer some of the questions that have been coming up. Yeah, so for those of you who are joining in late, yes, this is being recorded. You'll be able to watch the playback. We'll share the slides. You'll be able to replicate the experience. You'll even be able to pause me if I speak too fast. So it's all coming. Definitely going to have that. And we'll try and chop out the bits where Sandbox wasn't working as well. Okay, right, let's have a look. So hopefully for those of you who are having the client error, I think you may be mistyping something. So you have to put in the colon and it is literally, let me pop it up here. It is literally colon play movies. That's exactly the whole thing. So you can't not have the colon. So it's colon play space movies and that should run. Let's have a look at some of the questions. I'm just going to scroll up to the top and have a quick peek. Can relationships also have attributes? Yes. So hopefully you're all having a play with those and seeing those as they're being loaded. How can we know the depths of the relationships? Is it dependent on the number of links or taxonomy structures? So there are things we can do around that. So it's a little bit beyond the conversation of this thing for queries, but we do have a query coming up where we look at Kevin Bacon numbers and you can start to see the flavor of how we can expand out. And absolutely, we can write queries where we can ask how many hops out does a relationship go from a start point. So absolutely, you can do that. If we have time, I don't think we will because this is that's sort of a bit more of an involved query. But if we can, we'll try and cover it. But you will see examples of where we start doing these multi-hop queries in this movie example. What's the best way to describe the schema? We have a query for the schema. So do the examples and I'll come back. So when we come back in a couple of minutes, I'll show you how you can have a look at what the schema looks like, the data. And then we'll talk a little bit more about how that works with Neo4j. So we've got a question here. Is match more efficient than where? So it doesn't really matter. So the reason why we have those inline properties is just how we specify it when we're creating the graphs, and you can use that to retrieve data, but it has to be exactly the same. As far as the engine's concerned, if you do match p person name Tom Hanks and do match p person where name equals Tom Hanks, it's going to be the same. It's the same speed. The thing that's going to determine whether you speed things up or down will be things around setting indexes and how you set up the query. So that's beyond the scope of this particular webinar, but I do point you to resources which talk more about best modeling practices, best importing practices and that kind of thing. So you will have access to that resources. And certainly for those of you who watch me on Twitch and so forth, you know that I do a lot of stuff around load CSV and setting indexes and that kind of thing. So I will definitely point you to the resources for that. How do I get a list of all the nodes and relationships? Hang on to that thought, Rajendra. We're going to look at that when we've got some data. So once you've finished the queries, I'm going to pop back and I'll show you where you can do that. And there are queries about how you can do it as well, but I'm going to show you the visual way of seeing what you've got. How can we define the depth of the graph? That's totally up to you about how you write the query. So hopefully, Leila, you will have seen that as we were creating the graphs, you'll have noticed how we're chaining things together. And if you look at, for example, here at our Tom Hanks graph, you can notice we've already got depth going on. You can see how Ron Howard is connected to Tom Hanks via the Da Vinci Code, and Rosie O'Donnell is connected to Tom Hanks via Sleepless in Seattle. So you can already start to see, as we know two things are connected, we put that connection in and we keep expanding out. So Viren asks, are there constraints available? Yes, we can put uniqueness constraints in and that kind of thing. So that's beyond the scope of this particular webinar, but I will point you to the Graph Academy courses, which will cover all of that kind of stuff. So, I think those were all of the questions so far. Hopefully, you've all had a go with this. And I've got a question about modeling tools. I will come back to that towards the end. Hold that thought. Alex is going to remind me if I forget. Hold that thought. I'll show you the arrows tool so we can have that. So you've got a question here. In the Tom Hanks query, where was the alias of M and D? Right, let me quickly go back and I'm going to show you that. Oh, at the very bottom of the query. So here's our alias. So here we've got our alias M for this node here. Here we're creating an alias for D. So for those of you who've got the reference card up, remember the second one down, which said, actually, I've got it here, haven't I? I can go back to the reference card. Power. So here we said, this is a generic node. We're just in passing. We're not worried. Whereas here we've got the reference. So here I've got reference for node 10. I'm not bothering to specify the properties and I'm not bothering to specify the label, but I am creating a reference because I want to come back to this node at some point and ask questions about it. So that's what we're doing in this example here. So you see, we're going, well, I'm not specifying that this is a movie node. I know it's a movie node because I loaded the data in and I know that this is going to be a person node, but I've not specified it and you don't have to. But I have provided a reference so that I can then do something with it. And the example here, I'm saying I'm just returning I want to return that reference in its entirety. So hopefully that makes sense. And let's see what else has come up. Do we have any partitioning technique? I'm going to park that because that's probably, I'm not entirely sure what you mean by that question, but if you can, Vishnu, if you can come back and sort of give a bit more detail around that, and then it may be beyond the scope of this session, but we'll see what we can do. So Chris just said, I've run the first example queries and nothing returned. Chris, did you load the data? So you need to make sure that you ran this original query with the create data. So the way you can tell this is, let me just quickly give you an example. So you know how I talked about this icon here, the picture of the database? So if I click on it now, I've loaded some data. So coming back to a previous question where somebody said, how do I know what labels and nodes and relationships and whatever else I've got in the database? This is how, because when you load some data and then you click on that database, it gives you some information now about the database. And what you can see here, this number here, this tells me the total number of nodes I've got in the database. I've got 171 nodes in total in my database. And you can see here, I've got a node label of movie in action in my graph, and I've got a node label of person in action in my graph. So that's giving me some information about what nodes I've got. Now, we've got the same for the relationship. So you can see here, it's in gray, so it's probably not going to come up too well. But if you're on your own, you can click the database icon. I've got 253 different relationships in my database in total. And you can see here that I've got 6 different relationship types. I've got acted in, I've got directed, I've got follows, produced, reviewed, and wrote. So you can see the different ones in place. You can even see what properties I've got in action. And you can see I've got born, name, rating, released, and so forth. So this is where we can see some information about the property keys. And then coming on to Fountainhook's question on Twitch about the schema. So what we can do is we can have a look at what schema we've got. So if I do it's call db.schema.visualization there. So if I just hit that, it's going to show me what my data currently looks like. What does my graph currently look like? And you can see I've got 2 nodes here. So I've got my person node and my movie node. You can see what kind of relationships are going on between the nodes. So we've got this self-referencing relationship of person follows person. You can see the person directed movie, or a person wrote a movie, or a person produced a movie, reviewed and acted in. So you can see what's going on. So I've got some questions coming in about use case examples and sizes of graphs. I will come back to those when we do our next example. So I've not forgotten about you. I will come back to you in a second. So you can see here. Now, the key thing to bear in mind, and we're going to touch on this when we look at modeling tools. So I'm going to show you arrows at the end. So the thing with Neo4j that's a bit different, for those of you especially coming from a relational background, is with a relational database, you have to declare ahead of time, this is what my table is going to be. These are the primary keys that I'm using. These are the different, rows I'm going to have. So what my column header is going to be, what the names are. They're going to be strings. They're going to be varchar. They're going to be Boolean. You don't do any of that with this. Think of this as schema on write. So absolutely, you have to think what your data model is going to be, and we're going to show you that data modeling tool. But with regards to Neo4j and the graph database, it's schema on write. As you put data in, that's going to drive what your data model looks like. So it's quite different, and it also makes it very powerful, because if I decide I want to add a new node or I want to add a new label, I can do that straight away. I don't need to make any changes to the database. I don't need to tell the database, hey, I'm going to add a genre node. Don't need to do that. I just put the data in and it's going to run. So that's where it's slightly different. So you don't need to declare an actual schema ahead of time and say, this is what the data is going to look like. This is what I'm going to put into you. But you still need to be disciplined when you're creating your data model. So hopefully that answers that question. Okay. Oh no, so Francis said he's missed a step about the data. So very quickly, just for you, Francis, on the second thing, make sure you've run this. Everybody else, please don't run it, because otherwise you're going to end up with double data. But Francis, just make sure you've run this query here. Okay, right, continuing on. So you've had a look at this. So let's have a quick look at a couple of these queries. So hopefully, I'm going to pick one at random. So hopefully, for those of you, you've looked at, say, this one here, this query. So if we have a quick look at what's going on. So we're matching nodes with the person label. We're going to give it an alias, a reference of people. We're then going to return the names of those people. So people.name. We limit it to 10. And this, because we've not specified order by, we've not done anything else, it's literally just going to grab 10. And because we've already got some people nodes in the cache of the database, it's probably going to grab the first 10 that appear in the cache, and it's going to return them. So just as an example. And what you've probably noticed as well is it's not all about those lovely nodes and relationships. And it's great fun that we can do this, and we can move them around, and we can double click, and we can expand out the nodes and that kind of thing. We can also return tables too. So a common misconception is, oh, we can only return nodes. No, we can return tables of properties. That's totally doable. And as you can see here, we're doing this as well. Okay, so somebody's saying it's a bit hard to read. Let me make this a bit bigger for you. Hopefully that is a lot better now. My apologies if it was a bit small. So you can see here, just as an example, we talked about this query. So we don't match people, return people, limit 10. So we're going to return the first 10 that the database happens to have. So let's continue. I'm going to click the next frame here. So we are now starting to expand out what's going on. And what we are going to do is do some of these. So I'm going to start speeding up a bit because we've got about 15 minutes left. So for those of you who can hang on for a bit longer, we'll cover the modeling stuff. You can catch up again with the recording. But I'm very keen for us to do the recommendation one and the Kevin Bacon number one, because that's the great fun stuff. So what we're going to do here, so what you notice is we're starting to expand out. So these ones, again, same idea. I'm going to give you a couple of minutes to think these through, but very quick. Actually, no, I'm not going to say anything. I'm going to let you have a go at these. So I'm going to give you about 3-4 minutes to go through these. So again, same idea. Try and think what the question's asking and then run the query. And then I'm going to pick one of these and talk through what's going on, because the pattern's starting to get a bit bigger. We're starting to go from nodes to, whoa, big patterns. So again, 3 minutes. I'm going to go through some of your questions whilst you spend some time looking at that. So question Fountain Hook on Twitch has just asked, the IDs of the relationship the resulting query have negative values. Is there a reason for that? Yes, so that's coming from the DB schema visualization query. Yeah, no, exactly. I knew exactly where you're going. So what happens there is, because those aren't real nodes, what's happening is the database is pulling the stuff up. And what's happening there is it has to give it a representation, because we use internal IDs to uniquely identify nodes and relationships. But that particular data model, that schema, does not exist. It's not physical data. What's happening is the database is going away and creating a representation of what the current data model is in the database. And it gives it a negative value so that you know that's not physical data. It's a representation. It's a virtualized view of what's going on. So that's why it's got a negative value. It's a great spot there. Okay, so going to give it a couple of minutes before I pick a query. So question from ASD. How can I use Neo4j like source for user details in Spring Boot or Quarkus applications? Do you have examples? We definitely have Spring examples for Neo4j. So I'll see if I can dig out some links. If not, I will go through some of these biggie questions. If you've got anything about how do I use this with Java or Spring, or do you have examples, drop them in the chat. We'll pick up those, and then we'll follow up with an email along with the details for how to get started with Desktop as well, and Sandbox. We'll have the links for those. So if there's any particular ones, we will come back to you on those and follow up. Okay, right. So time marches on. So I'm going to have let's quickly go through this query here, because we've got the nice big one. So in this query here, let's have a look at what's going on. So we have we're matching person nodes, and we're putting it in our reference of people. And we're creating a reference in our relationship. Ooh, we know it's a reference because there's no colon. Notice no colon. So this is not a relationship type. This is creating a reference for this relationship because we're going to do something with it later. Then we go to movie. So we want to have the nodes with a label of movie. And we want to get the property, so a specific movie here, Cloud Atlas, so we're doing property title. And we're going to return the name of that person. And here we've got a function. So this is a Cypher function. And what this does is we give it a reference of a relationship. So here we've got this reference of related to in the relationship in the square brackets. And this will tell us what the type of that relationship is. And then this related to then just gives us something that looks like a JSON object. And this is going to tell us all of the information about that relationship. So let's have a look. Let's run that. So what we've got here, so here you can see we've got the person named Tom Hanks, and you can see this is Tom Hanks's relationship to Cloud Atlas. So he acted in Cloud Atlas. And then here's all the other information about the relationship here. So we've got its unique identifier. So this is the internal ID. This is the internal ID of the node that it started from. This is the internal ID of the node it came from. This is all detail we don't have to worry about. We've got the type, we've got all of the properties associated, and you can see here Tom Hanks had many roles in Cloud Atlas. And then you can say my idea. So you've got Jim Broadbent also acted in this, David Mitchell wrote it, Tom Tyker directed it, and so forth. So you get the idea of what's going on there. So that's what was happening there. And let's move on, because we want to do some Kevin Bacon numbers. There's no reason why we can't, we can't be doing graphs and not talking about Kevin Bacon numbers. So I'm going to quickly talk you through these as to what's happening. So here we have got our exciting stuff going on here. So we've got our square bracket. So we know we've got a square bracket. So we are looking at relationship. And you say, well, hang on a minute. What's this star1.4 business all about? So this is, so following up, somebody was asking about depth and querying in depth there. We are now going to be querying the depth of here. So what we're saying here is match Kevin Bacon. And then from Kevin Bacon, I want to go from one hop out to 4 hops. So I go from 1 node up to 4 nodes out, spanning. So I'm not specifying relationship type. I'm not specifying node type. I'm basically saying from Kevin Bacon node, please now go up to 4 hops out. That's what this star 1 to 4 is. And I'm going to give an alias, a reference for the node that you come up to of Hollywood, return distinct Hollywood. So what this is going to do is it's going to find all of the nodes from 1 hop out from Kevin Bacon up to 4 hops out. So all of those, it's going to give all of those nodes an alias of Hollywood. And we're now going to return distinct instance of those nodes coming up. And then we've got another fun one here, which is the shortest path. So be aware, it may be really tempting to go, oh, well, hang on a minute. I'm going to use this star because that means that's going to bring back all of the relationships. Please don't do this, because let me just quickly tell you what's going on. So whilst we've got quite a small graph, if you think about every single possible pathway that you can visit every other node, you'll be looking at millions upon millions upon millions of different combinations of how in our relatively small graph you can visit this. And this will take time and more, it will take forever to run this. So don't do that. But what you'll notice is we've got another Cypher function here called shortest path. And what this does is this says between my 2 nodes I've given you here. So here we've got Kevin Bacon and here we've got Meg Ryan. I want you to tell me what is the shortest path or a shortest path that connects Kevin Bacon to Meg Ryan. And then you can use this star because the shortest path function will automatically get rid of long paths. It'll go, no, not interested, not interested, not interested. So have a go at those. And then I'm going to skip past the recommendation one. I'm going to allow you, actually, no, I'll touch on it quickly. I'll talk through what's going on and I'll let you do that in your own time when you revisit the sandbox, which I recommend that you do. So I'll give you a couple of minutes to have a play with those 2 queries. We'll have a look at the other ones and then we'll start to wrap up and look at the other resources and what I recommend you do if you've been having fun with this. I feel really bad for Francis. I'm really sorry it's not working at the moment. Hopefully, when you pick this up later, it's going to work. So, got questions about Python Go, Kafka connectors from Marek. Yes, I will follow up with you in an email. We'll have all of that stuff. And yes, we do. We have all various connectors and drivers and things for that. So we shall follow up with you on that. If I question for agenda. If I have a huge database with lots of relations, is there change in fundamental relationships? Might it be challenging? So this is all about having that good data model, understanding what questions you're going to ask and that kind of thing. So I'm not going to cover it now because I'm not the right place. But again, I will point you to some resources that we have. So the Graph Academy talks all about modeling. I know somebody asked about whether, I think it was 20 million nodes or something. That's tiny graph. We've got people who've got billions upon billions of nodes and relationships in their graph. So there are some very, very big graphs. And the really beautiful thing about the graphs is that because everything's like, when you think about querying, it's local. It doesn't matter how big the graph is because you're always going to be zoning into the part of the graph that you're interested in. So yes, you can have huge graphs and it all works beautifully. Okay. Please go back through this example again. I think this is a fantastic starting point if you're new to graphs, the movie graph. So do go through this at your leisure. I'm just quite keen to quickly explain the next query because it is a little bit whoa, but it's totally cool. So I'm just going to pick this one and then you can work through this one and try and understand what's going on. But let's have a look at this query here. And let's talk about what's going on. So in this query, what we're trying to do is we're saying we want to understand. So we've got Tom Hanks. Tom Hanks is going to be starring in this new movie. And we're trying to figure out who would be good co-actors to work with Tom Hanks. But the sting in the tail is we want these co-actors that have never worked with Tom Hanks before. And the rationale that we're going to use to try and figure out who would be good co-actors to recommend to work with Tom Hanks will be based on co-actors he's worked with previously in the past, and then use their co-actors as potential, people that we would recommend to work with Tom Hanks. So let's step through what's going on here. So we've got our start point, which is let's find Tom Hanks. And then from here, we are going to find all the movies that he's acted in. So that's our reference point here for movie. And then from there, we're going to find all of the co-actors that Tom Hanks works with in these movies. From there, we are then going to have a look at those co-actors, and we're going to look at all of the movies that they've acted in and find all of their co-actors or the co-co-actors. So the co-actors of the actors become the co-co-actors. And then we're going to say, well, actually, we just want to make sure that we don't accidentally pick up Tom Hanks because Tom Hanks can't co-act with himself unless we get to cloning. We're not there yet. We're not in that universe. So we're not Tom is the co-actor. So that's effectively what we're saying here. So we want to make sure that it's not Tom's not the co-actor. And also, we want to make sure we don't accidentally pick up co-actors that Tom Hanks has worked with. So that's what's going on here, this where not. So that's just saying where that's not happening. And then we are returning the co-actors' names as recommended. So here we said that as allows us to re-alias things. So what's happening here is saying we're going to now call this recommended. And we're doing count star. And what count star is saying, so count star works on this group by principle. So depending on how filtered we are, so here we're looking at different co-actors, the co-actors of the co-actors. So this is basically going to count the number of common co-actors to a co-actor. So this is what we're saying is, so if 5 co-actors have the same co-actor, then that's got a higher strength, so that we're more likely to recommend that co-actor than, say, a co-actor that only has 1 co-actor. Do you see what I mean? Do you see where I'm going here? So basically, where more of Tom Hanks's co-actors have worked with that co-actor, the higher up we recommend them. So here you got this order by strength descending. So we're ordering it from the bigger number, so the number where the co-actors worked with more co-actors. And that's what's going on. I know it's a bit of a mouthful, so step back, and if you run the query and you can have a look at what's going on, you can see, as I scroll, oh dear, no, hang on, we're still in table view, that's why it is, there we go. So you can see here that we are recommending Tom Cruise because in our very small movie database, Tom Cruise and Tom Hanks have never worked together, but Tom Cruise and Tom Hanks have a lot of co-actors who have worked together with both Tom Cruise and with Tom Hanks, which is why he's got that high strength. So please do have a go at that. So let's have a look at where you can learn more and what do I recommend you do next. So I'm just going to quickly skip through all of these. So how do you continue your graph journey? So number one, we went really fast with this. I love the play movie graph. I think it's a really great way of just being thrown in there with a data set that's familiar to all of us. We all watch movies. I assume we all watch movies. We're aware of the actors in there. This is a really great way that you can start to work with this and just understand what's going on. So come back to this, rewatch the video, pause it in places if you need an explanation of some of the queries, step through the example. If your sandbox expires, you can always come back. If you use Neo4j desktop, you can always run play movie graphs from absolutely everywhere. So do have another go, step through it, make yourself feel comfortable with it. So if we can continue from there, we have got our online developer conference. So this is now, this will be its third year. So we started Neo4j Online Developer Expo and Summit in 2019. This is our third year. This is a developer-focused conference. It's completely free. We will have beginner content there. We'll have stuff for those of you who want something a bit more challenging, but we will have content for everybody. So please do come and join us. I talked about Graph Academy several times. I know Alex has put the link in as well. So this is a really great way to effectively go away and learn at your own pace. So this is guided online training. We've got everything from introduction to Neo4j, introduction to Cypher, to modeling, how to do the administration. We've got a data science one as well. So you've got loads of exciting content there. It's completely free. You also have the opportunity to do our Neo4j certification. Again, completely free. So do check out that content. We also have our YouTube. Oh, this is our put on the YouTube channel. So on our YouTube channel, you will find this session on our YouTube channel. You will find all of the various Twitch streams and sessions that we do. So I stream, my colleagues will lion stream, as well as Florent. So we all do videos on there. We have all sorts of fun stuff on there. Do check that out. And you've got the links there as well. We also have our community forum. So I've put that link there. So I think somebody asked, where do I ask questions? So if you've got a question on here's a data model I'm working on, how can I do it better? I'm stuck on this query. Here's a use case I'm working on. If you want to just tell us what you're looking to do as well, come join us in the community. So that's community.neo4j.com. Come check us out. If you need to ping me about something, you've got my details there. I tweet a lot on Twitter, so if I'm going to do a stream or something like that, or I've written a blog post, I will post things on there. So if you're interested in what I'm doing, you can contact me there. Also at neo4j.com as well. So that's where we will highlight any events and things going on. I'm going to dwell on this slide because notes, please join us. Graph Academy, do join in and check out our playlists on YouTube as well. So before we wrap up, I did talk about arrows. So let me bring up arrows, and I think Alex has pinged some links on there as well, and we will follow up with the email. For those of you who've got your email details, we will follow up with the various links and things we talked about that we've promised. So this is Arrow. So this is a very lightweight way of being able to work with data models. So again, you can use pen and paper. Pen and paper is totally acceptable. So you remember how we talked about that you don't have to specify your schema ahead of time when loading data, because we do schema on read. So as we are, or schema on write even. So as we are writing data into the database, this is going to give us our schema, and it adapts. but you still have to think about what your data model is going to look like. So pen and paper, completely acceptable. A whiteboard, completely acceptable. If you want some diagramming tool that's a little bit sort of +1, then a whiteboard or a piece of paper, then you can use Arrow. So that's arrows.app, and you have this. And this is a nice lightweight tool that allows you to create diagrams, and you can also share these models and that kind of thing. So just very quickly, this is it. If you're interested, we'll make sure that we have a link to Arrows as well, but very quickly, I can create a node. I can add a label on here. I can add some properties on my node, so name, I'm going to do Lju. I can add other nodes as well, so I'm going to do webinar. It has a property. Title, it has intro to Neo4j. Oh, we've forgotten Alex. We've got to add Alex on here as well. Alex was also, oh, I didn't mean, oh dear, didn't mean to duplicate that. Just get rid of that. I'm going to just reuse this. So we've got our two nodes. We can then say, well, they have a relationship to this webinar, and we can say, well, actually, that is host. We can also add some properties as well. So let's do date, and today is the 11th, so 2021, 0311. I'm just going to copy that. Same idea. And there you go. So you can see I can very quickly create a data model, and we can do stuff with this as well. So what we can do is I can download and export. So if I want to share this with somebody, I can copy this link. So it's generated effectively how to create this graph. So I can copy this link and share it. If I want to import this into Arrows, I have an option of downloading the JSON. If I wanted to create this into Neo4j, I could create this. I can press the create thing. I could like copy this code and create it. So that is a very quick whirlwind tour of this. So this is a really handy diagramming tool. So I use this to create diagrams in various posts and things like that. Yes, so Dinesh has just posted the link of the Arrows. So that's the old version. This is the new, shiny, brand new version of Arrows here. So that's it. So I think we've picked up most of your questions. Thanks for dropping in the questions with regards to connectors for Kafka, that kind of thing. We'll follow up with that so that you've got links for that. And I know loads of you asked questions about the modeling, constraints, that kind of thing. So do check out the Graph Academy. We have a lot of stuff around that as well. And we have a lot of content in your, if you check out our Medium, so at medium.com/Neo4j, you'll find a lot of content there as well about importing data and modeling and that kind of thing. So I'm going to bring back Alex.
Hello.
Hello.
Hello. Yeah, perfect. Thank you very much, Lou. That was great. Thank you all for joining, for participating, for asking so many questions. Sorry for the slightly technical difficulties we had with Sandbox, but that's sometimes how it is. I mean, if you do it live, then Murphy's Law, you know how it is.
The demo demons. It's
demo
always
demons, exactly.
Demons.
Yeah.
How cheeky they are.
Yep.
But yeah, thank you so much, everybody, for joining. I hope you had fun. Please come back and have a go at the movie graph. We went through that so fast, and there's so much fun stuff in there. So please do have another go at that. And yeah, have a go at the training. So much fun, so much to be learned.
Absolutely.
Cool. Well,
cool. All right. With that, I think we wrap up. Thank you all.
Absolutely.
And
thank you very much, everybody.
See you soon.
Bye.
Bye.